Welcome. So this will be a small introduction to show some features from Tyrhex, which helps to analyze on byte level some forensic cases. So we have here some forensic image produced, but what you want, like DD from Linux and so on, is a small image, but it works with Flash and tab. So I will select this image and start using Tyrhex on it. So immediately I get the confirmation and I can find that in the report. What we have here is the byte representation, and the offset. So the cursor is located at the first offset, which is always expressed in absolute. So it's in bytes and sector 0. So if I go to the next sector, 1, and so on. So, however, we have here something which is interesting is that it seems to be the volume descriptions. So that's the main partition table. So we can get all the partition, will it be MBA or GPT, using only the analysis system. And it creates automatically the partition detected on the system. It makes a quick check about the description in the MBA or the GPT and the real content of the partition, in case of sometimes it can be different. And it goes to search for the volume name where it can be located, depending of the file system properties. So if you look on that, you can still move everywhere. So I can move here, and you see that at the end of the disk, after the last partition, there is only one, I have still data. It is probably data remaining from a former use of the device. And anyway, yeah, sometimes for investigation it can be interesting. So I go back on the beginning of that. And I go to the volume descriptions. And I see here that I have the only one volume detected, which is available. I can get details. And you can change it. So it can be used, but it is not the purpose of this demonstration. For creating or rebuilding partition, I can change the color. I will put a more darker green, and I can change all the settings. So that's my volume. And he already detects when he creates a volume a lot of things about the structure of the volume, like the start of the partition, the position of the root folder, and the position of the MFT. If I want to go deeper into analysis of this volume, I have to lock it, to use the architecture of the volume to help me to find the things. So I will lock it, and if you see, when I lock it, something changed. First of all, I will get information about the structure of that. The most important one is that the fact that a block or a cluster is made of several sectors, so in this case 8 sectors, and because NTFS it is starting from the beginning of the partition. For FAT, for instance, it is starting on the data heap position. And on the overview of the disk, I see that my partition is now bordered with a wet border, which means that it's the selected partition. If I unselect it, it becomes unselected, and I will lose this border. Automatically, it comes in the most important part for the NTFS. It's the start of the MFT. So I'm here at the start of the MFT. For the people who know NTFS, we have the F, I, L, E, 0 characters in ASCII and a lot of things. I can manually decode things, for instance, here. Value. That's the date time, which is already decoded. The decoding is sometimes interesting when we are using that for training purpose, because you are coming here and you can see will it be signed or unsigned, and because it is working on a partition, it is Little Indian, or however you can use Big Indian if needed. And more than that, for instance, the C6, you can have the binary representation of the bytes in hexadecimal. It can be used for the flags explanation and things like that. So that's one thing. What you can do is analyze manually the content of the NTFS record. And one interesting feature of Tyrhex is that you can use the magic jumping. So the magic jumping is quite simple. If you know NTFS and MFT file record, all two attributes have two major fields. It's the first, which is here for the first one, is the description of the attribute type. In this case, 10.0.0.0.0.0. It means that it is standard information attribute, and it's immediately followed by the size of the attribute in bytes, hexadecimal here. The fact is that it should be interesting to go to the next one, but to go to the next attribute, you have to compute it. But it can be easy if you use the facilities provided by Tyrhex. The first of all, I have to set the magic offset. So I set the magic offset here, and I'm going on the size of attributes. It means I want to move from this size, which is 96 bytes, sorry, here, from this position. So we are speaking about bytes, and we want to use the magic. So from now, it's quite easy. I will go on to value, and I click. And automatically, it moves to the new position. But what's more interesting, it not only moves, but it moves the position of the magic. So I will go here, and now I will move by 104 bytes from this position. If I click here, and to move. I'm now on 80. 80 means that it is data attributes. I will move, and I come on B0. Move, and I'm at the end of this record. Anyway, it's the first way to analyze the things, but we can use another way. It is analyze straight using Tyrhex features, and it gives you what's available. However, it's depending of the file system. For FAT, it's different from NTFS, but we got that. What's interesting with NTFS that every record have a number. So what we can do is moving by numbers. And when this record contains a description of a folder, however, you get the name of the folder and all those indications, but you get all the names of the files in the folder too. And to go in other files, you don't have to browse record by record, but you can use this representation. For instance, we have public, which is a folder. I click on it. I have all the files in public. I click on this file, pic.jpg. It's quite easy. So what's interesting, if you look here, is that the decoding is quite a bit forensic already, because you get the information that there are several data information. The first one is pic.jpg. It seems to be the main file, but afterwards you have the alternate data streams. So if you want to go to the position of the content of the data streams, for instance, the ok.txt data stream, which is a named one, you can go straight to the content, and you see you are at the beginning of that, which is following immediately the name of the stream. You can do the same with the non-resident one, which is the pic.jpg. So I go here, and I am at the beginning of the file, which seems to be corrected. FFD8, it seems to be a JPEG file. Now, I want to go back on the description into MFT of this record. I click here, and I am again back on the record. What you can do with the record is using what we already did. So here I will offset, setting the magic offset. Again, here, byte, magic, it's okay. So I click, and I'm browsing in my attributes. Yep, first data attribute. Second one, oh, it's logical because we have several data attributes due to alternate data streams. And I'm the end of the record. So I can come back and select sector before, at the beginning, analyze, and I have my record analysis. You see here that a list of block fragments is available. It's only the data runs, so the different cluster containing the content is a non-resident attribute. So everything is listed and you have the amount of cluster that you have here. So you can recover manually if you want, because you can get the first cluster and the following ones. However, what we can do is working a bit different, but I will come on to that later. So we are working on a file, and it's a case. We want to come back 1 week later on that. So I'm in an interesting place. I want to create a new bookmark, and I will create a bookmark saying interesting file. Oh, interesting file, big.gpg. And I will put a color, and I create a bookmark. When you look to the bookmark, you always can have the position. It's always the absolute position, or in offset in byte, or offset in sector. And what's interesting is that you have here the description, because we selected the volume of the offset relative to the beginning of the volume in bytes, in sector, and because a volume can have blocks larger than sectors, you can have the value in blocks, taking in account the heap and so on. I think we make a good overview of all what's available. What's interesting is when I used the magic, the history was populated, so I can always come back on some of the jumps if I want. So I already spoke about the volume and so on. So the only thing that we have to do now is saving the case. We call it demo. And the case is saved. It means that the next time that I want to reuse it, I don't have to open the DD, but I have to open the case. And instead of having everything to redo, everything what's done, including the report, will be reload, including the bookmarks and the file, however, and so I can keep working on this file, saving it again at the end of the work in order to be better and to retrieve other things. So thank you for your attention, and perhaps for next demonstration about other features from Tyrhex. Thank you.